In this video on working with subpopulations, I'll talk about breaking populations into segments in VisMiner, putting models on those segments, and then picking a model per leaf node, and then show the example of applying a compound model. I'm going to take this and create a filter data set. In my first subpopulation, it only goes up to that $100,000 range. And it's not exact, but this is close enough. So I'll say less than 100K. This has from 0 up to 300K, so I'm going to drag this up and make a data set from the difference. In VisMiner, you have to make sure that the children are mutually exclusive, in other words, no records in both of these, and that when you add these up together, they all must meet the parent. Otherwise, it makes it an ambiguity so that you can't route a specific instance down to only one particular subset and therefore only one model. In this, I have everything up to 100,000. Over here I have from 200 to 300,000. I'm going to rename this because I find that it's really helpful to be able to keep myself straight on what's in each. And to review here, we have 30,000 of root mean squared error on this one, which was all of these homes. Let's see how much better we did when we do just those that are less than $100,000. The error should go down. And it does. It went down substantially. It dropped in half to be about 15,000. So my first sort of decision was a useful one. And I could try a variety of different algorithms on this. I'll try a KNN model on this as well. And make it relative to distance. It didn't do any better than my linear regression, so I'm going to delete that. I'm just going to leave one model on here, the one that was the best one. And then I'm also, just for my own curiosity, I'm going to see how well a linear model does on this that ranges from 100,000 up to 300,000. Looks like I misnamed this. This actually should have been named 100,000 to 300,000. Now, how did I do? How does this? This still has a very high error. This is about the same as we were doing when we were looking at the error overall. So we still have some sub breaking down to do here to get things actually to work better. So I'm going to take this and I'm going to create another filter data set. I'm going to make it so that it's down to between 100 and 200,000. And I'm just selecting these break sizes fairly arbitrarily. And gave it a descriptive name. And so now I've got the first 1 to 200, and I'm going to get the difference here again just to make sure that I've got all of my data here. So now I've broken this into two pieces, from 1 to 200, and then I'll rename this so it's descriptive. This really should just be 200 to 300,000. And I know this isn't very good. That was about 30,000. I'm going to delete this. And now I will put a regression on each one of these. Okay, so see how we did. So this is 20,000, and this is 22,000, and this is about 15,000. And so each of these is better than when we were trying to put all of that diversity in there together. And I could try different breaks. I could try, instead of breaking on price, I could try breaking it down by bedrooms and by bathrooms and lot sizes and things like this. I just chose one, and I've made sure that each of my children add up to the parent. So I should have met all of the constraints necessary now. I know that my overall model was about 31,000. I'm going to delete this now because what I want to do is I want to be able to put a compound model up here and a compound regression and see how that works. So my compound regression is better. It's 21,000. And remember, when I did a one-size-fits-all model up on that top parent, I had a little over 30,000. So I do get some benefit by breaking into subpopulations and then putting a compound model on there.